Section 12.2, geometric sequences and series. Remember in section 12.1 we talked about arithmetic sequences and series. We have a second type of sequence and series, and that would be a geometric sequence. The difference between arithmetic, man, I'm struggling today. Arithmetic sequences and geometric sequences. Remember, arithmetic, we're adding or subtracting the same amount. In geometric sequences, we're basically going to be multiplying or dividing by the same amount. And usually we use multiplying, even if we're getting smaller. So even if we're dividing by 2 every time, we're going to say that we're going to actually be multiplying by half. Remember, they're the same thing, but the common ratio, it is involving multiplication every time. So geometric sequence, a sequence in which the ratio between consecutive terms is a constant. So for example, you could have 2 and then 4 and then 8 and then 16 and then 32 and then 64 and then 128 and so on down the line. That would be an example of a geometric sequence. We're multiplying by 2 every time. So we go times 2 and then times 2 and then times 2 and then times 2, and you get the idea. Okay, the common ratio, the ratio of successive terms, that would be 2 in this case. Okay, so let's jump right into some examples. Find the common ratio and the next 3 terms in each sequence. So number 1, we got 4, 6, 9, and then the pattern continues. So I got some hints here. So to find the common ratio, divide a term by the previous term. So we can't start with the first term because there's nothing before that, but we can start with 6. And if we take 6, let me try that again, 6, and divide that by 4, what we're going to get is we're going to get 1.5. Okay, so then we can try it again. We can try 9 divided by 6, and you can type this in your calculator if you want. What you're going to get there is also 1.5. So what you can say is that your common ratio, and usually that's denoted by R, the common ratio is equal to 1.5. Now, once we find the common ratio, we can multiply the last term, or whatever term we want to use, by the common ratio to find the next term in our sequence. Okay, so we can take 4, well, if we did 4 times 1.5, we would get 6. If we did 6 times 1.5, we would get 9. So we don't want to use 4, we want to use 9. And so we're looking for the 4th term, so a sub 4, we're still using that subscript notation. A sub 4 is going to be equal to 9 times 1.5. Let me actually make this a times 1.5, and what we're going to get when we do 9 times 1.5 is we get 13.5. Now, if we're looking for the next 3 terms, so that's going to be the 5th and the 6th term as well. A sub 5 is equal to, we will use the previous term, so that's the 4th term, which was 13.5, times our common ratio of 1.5, and when we take 13.5 times 1.5, we're going to get 20.25. And then we need to find the 6th term, so a sub 6 is equal to our previous term, which was 20.25, 20 1/4, times 1.5. Again, just type these numbers in your calculator to find the answers. It's going to be 30.375. Let's try another one here. 21, 4.2, 0.84. The first thing we need to do, we need to find the common ratio. So we're going to take the second term, 4.2, and we're going to divide it by the previous term, which was 21. 4.2 divided by 21, when you type that in your calculator, is going to be 0.2. And just to double check, make sure it is geometric, we should take 0.84 and divide that by 4.2. And when we do that in the calculator, we do also get 0.2. So I think it's pretty safe to assume that our R value is 0.2. So we have the first 3 terms. We need to find the next 3 terms. So that would be the 4th term, the 5th term, and the 6th term, a sub 6. Okay, so the 4th term, we're going to take the 3rd term, so 0.84, times our common ratio of 0.2, and when we do that, what we're going to get is 0.168. Okay, when we find the 5th term, we're going to take our 4th term, 0.168, times our common ratio of 0.2, and we're going to get 0.0336. And then for the 6th term, we're going to take our 5th term, 0.0336, times our common ratio of 0.2, and that will give us 0.00672. Again, this is all calculator work, just typing some things in. After you do the first and the second, you can actually just hit enter here if you just keep going with times 0.2 to do it pretty quickly. Formula for geometric sequence. There is a formula just like there was for arithmetic sequence. The formula for a geometric sequence, let me write this here in black. A sub n is equal to a sub 1 times r to the n minus 1 power. Remember, a sub n stands for the nth term right here. A sub 1, just like in 12.1, is the first term, and then your r value is your common ratio, and there it is. Okay, so these are the three main pieces of information that we're going to need to know. Just like in arithmetic, the n's will be the same number, and we'll go ahead and do a couple of examples here. So approximate the 12th term in the sequence. So in this case, we're saying that n is going to be equal to 12. Okay, before we can actually figure out what the 12th term is, we're probably going to need to know the common ratio first. So once again, we're going to take the second term, 26.4, divided by our first term, 24. When we do that in our calculator, we're going to find that it's negative 1.1. Again, just to be sure, we should do this third term divided by the second term, so negative 29.04 divided by 26.4, and that also is negative 1.1, so then it's pretty safe to assume that our r value is negative 1.1. Whoops, don't need parentheses there. Okay, so once we have the common ratio, then we can go ahead and figure out what the 12th term in our sequence is going to be. I'll do this in green. So a sub 12 is equal to our first term, which was negative 24, so we'll say negative 24, times our common ratio of negative 1.1 to the, let's see, what is it, 12 minus 1, n minus 1, so 12 minus 1 power. If you want to type this in your calculator quickly, you could go negative 24 times negative 1.1 to the 11th power. Just make sure negative 1.1 is in parentheses. Negative 24 doesn't necessarily have to be in parentheses, but I'm just putting it in parentheses for organization's sake. When you type that in your calculator, what you're going to get is that this is going to be 68.5. This is a rounded answer, so I don't know if I should have the equals there. So if I erase this, I could put the wavy equals. It's about 68.5. It's a very long decimal, 68.47480095, and I'm sure there's more to it after that, but that's what the calculator shows me. So if you want to round to one decimal place, or maybe even 2 or 3, no more than 3 will be fine. Okay, number 2, 256. 179.2, 125.44. Again, we need to find our common ratio first. So we're going to take 179.2 and divide it by 256. And when we do that, we're going to find that is 0.7. Again, 125.44 divided by 179.2. That is also 0.7. So then it's safe to assume that the common ratio here is 0.7, and then we need to find the 12th term. Again, I'll do this in green. So a sub 12 is equal to our first term, 256, times our common ratio, 0.7, raised to the 12 minus 1 power. Again, if you want to type this in your calculator quickly, 256, parentheses, 0.7, close parenthesis, raise that to the 11th power. And what you're going to find, again, this is a rounded answer, so it's approximately 5.06. So I'll kind of leave it up to you if you want to do 1 decimal place or 2 decimal places. If you want to do 3, feel free to do that as well, but you don't really need to do any more than 3. But for sure, give me a couple of decimal places. I think 69 and 5 are a little too far rounded, but 1 or 2 decimal places is probably enough. Just as in Chapter 12, Section 1 with arithmetic series, we do have geometric series. The definition is exactly the same. The sum of the terms of a geometric sequence, this time instead of arithmetic sequence, but the idea is the same. We're adding terms of a geometric sequence, whether that's the first 10 terms or the 12 terms or whatever. We do need a number because sequences and series go on forever. So if we're looking for the sum of all the terms of a series, then it might be a little difficult. But if we're looking for the sum of the first 10 terms or the first 8 terms, like you can see here on the screen, then it's something we can do. The formula for a sum of a geometric series, just like with arithmetic series, S sub n is equal to, here's your formula, a sub 1, so the first term, minus a sub 1 times r to the n power, all over 1 minus r. That is your formula for the sum of a geometric series. S sub n is equal to a sub 1 minus a sub 1 r to the n, all over 1 minus r. So I've got one example here for you. Find the sum of the first 8 terms of the geometric series. So we don't need to know the last term, because remember, in the arithmetic sequence or the arithmetic series, we needed to know the last term. We don't need to know that. That's kind of what this will do for us. We'll find the whatever term, in this case the 8th term, for us. This is a lot of stuff that we can just type in our calculator, so we don't need to worry too much about simplifying things down. We just need to make sure we use parentheses appropriately. So the first term, a sub 1 here, is 14. Our common ratio, that's what we need to find first. We need to know that before we can plug this information into our formula. So we'll take negative 70, second term, divided by the first term. Negative 70 divided by 14 is negative 5. And again, we should just double check one or maybe both. I'm just going to do one. 350 divided by negative 70. That one's easy. That's negative 5. We do have a common ratio of negative 5, so our R value is negative 5. Those are the two things we really need to know to be able to use this formula up here. So let's just go ahead and plug things in. So S sub 8, the sum of the first 8 terms of this geometric series, is equal to our first term, 14, plus our first term times our common ratio, negative 5 to the, let's see, we got the n power, so that's the 8th power, all divided by 1 minus our common ratio of negative 5. So if we want to simplify this down, I would do it this way. I would say 14 plus 14 times negative 5 to the 8th power, all over, let's see, 1 minus negative 5 is positive 6, and this is what I would type in the calculator. Parentheses wise, I would put a parenthesis before the first 14, after your exponent of 8. If you want to hit enter right there and without the parentheses, you could do it this way. Just type this in your calculator, the numerator, hit enter, and then divide it by 6. Or if you want to type it all at once, put parentheses around the entire numerator and then divide by 6. And either way, you're going to get the same answer when you add up the first 8 terms of this geometric series. So these numbers get fairly large pretty quickly, bouncing back and forth between positive and negative. Your final answer here, the sum of the first 8 terms of that geometric sequence, or geometric series, pardon, is negative 911,456.